support me on Patreon so I can keep my lights on. If you decide to recreate anything, it is at your own risk and I do not accept the responsibility. Also, join the Discord. We have a lot of sophisticated conversations. Also, huge thank you to these admins. They did a lot of work on the Discord, so make sure you thank them in there. Alright, I know what you guys are thinking. Why is Chemdelic making piperonal? Well, it smells good. We'll go with that. To start the project out, we're actually going to need some black peppercorns. I decided to get mine off of Amazon just so I could do some tax write-offs. Step 1 is to extract piperine from black pepper. Piperine is responsible for the pungency of black pepper. Essentially, it's that thing that really makes your nose itch when you have it on food, and you do that really big dad sneeze once you get it in your nose. Black or white pepper can be used, as they both contain the piperine. What we'll need to do now is grind these up into a fine powder, as these are the whole kernels as of right now. For my extraction, I'm going to use 50 grams of the black peppercorns. Black pepper generally has around 5 to 9% of piperine, so that should give me about 2.5 to 4.5 grams of piperine. Since I have the kernels, I'm going to need to use a coffee blender and get this down to that fine powder so I can extract as much as I can. And the best part of this whole entire extraction is we're going to use a new piece called the Soxhlet extractor. The Soxhlet extractor was invented in 1879 by Franz von Soxhlet, and it's primarily used to extract compounds from solid material. What we'll first need to do is put some cotton at the bottom, and then we're going to put our ground black pepper on top of it. The reason for the cotton is essentially to act as a filter for the solvent to go through. We want to make sure that the cotton is pressing against the hole at the bottom, as this will help the solvent move through the system a lot easier. Essentially how it works is the solvent will reflux, it will condense, and it will drip over the cotton and black pepper sandwich. It will then build up enough pressure in the tube to push the solvent all the way through and all the way back into the round bottom boiling flask. The solvent that we'll be using today is isopropyl alcohol. Ethanol can also be used, but I had isopropyl on hand. The benefit of using the Soxhlet extractor is that you have fresh solvent each time it goes through an extraction. As you can see, the isopropyl alcohol has refluxed and it is slowly dripping down into the tube with the black pepper. The isopropyl alcohol will then pass through all the ground black pepper and it will fill up into the container. This is a sped up version of the video, and you can see that the isopropyl alcohol slowly makes its way down, all the way down to that bottom section. This tube will fill up slowly with solvent, and the pressure from all the other isopropyl alcohol will push it all the way up and all the way back down into that round bottom boiling flask. Once it gets to the top of this tube, it's kind of like flushing a toilet, and once you let it go, all the other solvent will follow and back down into the round bottom boiling flask. Here you can see the color from the extraction, and you can see the isopropyl alcohol slowly make its way up that tube. This video is sped up and it took about 20 to 30 minutes to get to this point. The unfortunate part is my Soxhlet extractor has kind of a defect in it. Although the cotton is pushed all the way down covering the hole, it really didn't seem to get to the top that well. Eventually, when it did get to the top, it just did this really slow dribble back down into the round bottom boiling flask. That is not supposed to happen, and it's supposed to be a pretty fast flow into the tube. The Soxhlet extractor essentially was giving me the blue balls of the chemistry world. Essentially a lot of foreplay, but definitely no end result. You can see that it's just hovering there, laughing at me diabolically. I know you can't hear this in the video, but I essentially was screaming at it to go up. More! I tried tapping on it, just like that girl in Finding Nemo, but it didn't seem to do anything.
Bro, please, bro, why are you do?
You can see that it's dripping back into the round bottom boiling flask, and that the solution is now a darker color due to the compound dissolving into it. I actually decided to manually push everything down, and you can see that it actually flows a lot better when that happens. You can also see in the video that the isopropyl alcohol is slowly draining and going all the way up into that tube. This is essentially one pass, and normally the Soxhlet extractor will go through a couple of those passes, and you can stop maybe around 4 or 5 of them. Really, the best way to do it is to let it run for about 1.5 hours to 2 hours, or when the solution is running pretty much clear. Here you can see me manually push it down, and you can see that the flow goes all the way up the tube and back down to the round bottom boiling flask. Now, it's not the best way, and it was very unfortunate that it happened to me, but chemistry is not all sunshine and rainbows. Now, I am going to have to filter this, as a lot of the black pepper actually got into the round bottom boiling flask, but that's no problem, and it can just be filtered pretty easily. I decided to filter through some cotton, however my natural bad luck decided that that was not going to happen today and I had to use a coffee filter instead. As you can see, nothing is filtering through it, so I don't even know why I bothered with the cotton. Coffee filters have become probably the #1 staple in home chemistry, I think. Anyway, you're going to filter the black pepper extract into a new round bottom boiling flask, and you can see that this one filters a lot better. Now the filtration will take some time, so what we're going to do is we're going to make a 20% solution of potassium hydroxide in isopropyl alcohol. This will react with the fats and the acids and make them more water soluble. A stir bar was added to a 50 milliliter beaker, and 4 grams of potassium hydroxide was added to about 20 milliliters of isopropyl alcohol. This will take some time to dissolve, and you might use a little bit of heating to get this to fully dissolve. Once it was finished filtering, we're going to set up for a simple distillation. The point of the distillation is we're going to reduce the volume by around 70%, and then we'll add the potassium hydroxide and isopropyl alcohol mixture into it. Here you can see the isopropyl alcohol coming over, and I would save it just in case you're going to do another extraction of black pepper. This way you can reuse your solvent and you don't have to waste any more. Once we reduce the amount by about 70%, we're going to add the potassium hydroxide and isopropyl alcohol mixture directly into the boiling flask. Once you add it, you'll see that there's this precipitate that comes out, and you'll see it kind of stick to the sides of the glass. This is the reaction of the acids and the fats that came over with the extraction, and when we add water in the future step, you'll notice that they're pretty water soluble. This is because the addition of the potassium hydroxide makes them more water soluble. We're going to let this stir for about 60 to 90 minutes, and then we're going to filter through a coffee filter and extract the filtrate at the bottom. It would also be a good idea to wash your flask a couple times with isopropyl and filter that through the coffee filter as well. I see so many people use cotton, and I just literally can't. It just does not work for me. Maybe it's just too densely packed. I'm just not sure. I also decided to wash the filter a little bit just to make sure that we got everything into the flask. As you can see, here is our lovely green filtrate. Now we're going to reduce the solubility of piperine by just adding water. Here you can see once I add water, the color changes to more of a yellowish color. This is the piperine that's slowly crashing out of solution, as it's really soluble in the isopropyl alcohol, and it's not really soluble in water, so we're just going to increase the amount of water in solution. This is definitely the money shot of part 1. As more and more water is added, you can see the solution does take on more of a yellow, and you can see the precipitate of the piperine coming out of solution. It's always quite an interesting experience when you get to do this in chemistry, and I like to do it every single time. You're going to keep adding water until no more piperine precipitates out, and once you do that, you can then filter and collect your piperine. I did speed up the video just because I want to show you exactly where I stopped adding water, but I probably could have done it just a little bit sooner than this. I also decided to do the wizardly swirl of the flask just to make sure that everything was mixed and a homologous mixture. You can see that the opacity of the mixture has greatly increased and that we have quite a yellow solution now. Now we're going to put a piece of saran wrap on the top, and we're going to put this in the refrigerator for about 24 to 48 hours. This is just to make sure that everything is crashed out and that we have a lower solubility of the piperine in the solution. After the 24 to 48 hours, we're going to filter everything on a piece of filter paper and make sure that you use a pretty fine filter paper, just because if you use like a coffee filter, a lot of the piperine will get through. I actually ended up using 2 filter papers for this, as I had a pretty fair amount of piperine. After letting it dry somewhat, you can see that we have a pretty fair amount of crude piperine. I decided to go for a recrystallization, though looking back at it, I really shouldn't have, and I could have used the crude piperine for my next reaction. I noticed there was a very strong black pepper smell, and this was a good sign that we actually had the piperine. It kind of looks like earwax to me, to be honest. After letting it dry, I put it into a beaker for the recrystallization. We're going to be using the isopropyl alcohol again as the recrystallization solvent. Once isopropyl alcohol was heated up, we're going to add this into our beaker, and we're going to add minimal amounts until everything is dissolved. I actually ended up using too much isopropyl alcohol, and unfortunately I did not boil it off. It is a good idea to boil off some of the isopropyl alcohol if you do use too much, as sometimes it can affect the recrystallization when that happens. After stirring for some time, everything is dissolved, and we're going to let this sit for maybe around 30 minutes to see if any crystals form. It's not pictured here, but after cooling it to room temperature, no crystals formed, and I ended up putting it into the freezer for a freeze precipitation. It really did not make any crystals, but it did clean up the piperine a little bit, and it did look a little bit better. It was filtered through a coffee filter again, and it was let dry in the filter. The recrystallization beaker was washed with some ice cold isopropyl alcohol, and we added that into our filter. You can see that our filtrate is still quite yellow, and you could probably do another recrystallization and get some more out of it. I just opted to not do that. Here you can see the much cleaner piperine, and it looks a lot better. Here you can see that I'm pretty garbage at extractions, and we only got about 1.462% recovery. I did the extraction again, this time with ethanol, and I actually got about 2.4 grams, which was about a 4% recovery. Part 2 is now commencing, piperine to piperic acid. Now I decided I was going to make a lot of piperic acid, so I'm going to start out with 42 grams of piperine. I took the extracts that I did, and I also did one more extraction. This extraction was quite successful, and I extracted piperine from Amazon. A perfect 100 gram recovery was about $40. The nice thing about starting with the extract is there's no additives in this, and it's just straight piperine. This saves a ton of money and time when you do it this way. Once we have our piperine, we're going to add 240 milliliters of 95% ethanol. Pure ethanol is a lot better, however 95% also worked for me. This is a scaled up version of Chemplayer's procedures, and all credit goes to him for all of these procedures. We're now going to add 30 grams of potassium hydroxide into the ethanol solution. I find that the 95% ethanol definitely made this a lot easier to dissolve into, and we're going to stir this around until everything is dissolved. Once everything was essentially dissolved, we're going to add our piperine into the mixture. The addition of the piperine does not need to be slow, and everything can just be thrown into the flask. I find that using a funnel is a lot better idea, as it's not going to stick to the neck of the flask. The color of the solution can vary, as if your piperine is more crude, it will change its color. However, I use a pretty pure extract of the piperine, and mine was a pretty yellow color. Initially upon the addition, you'll see that it doesn't dissolve quite easily immediately, and you're going to have to stir for some time. While it's stirring, you're going to set it for a reflux. The reflux will be performed for about 2 to 3 hours, and as you start to heat up the solution, you'll notice that it starts to get more and more clear, and that it's going to change color. The more pure your piperine is, you'll notice that it is a orange to a yellowish solution color. In case you're curious, this is a simple reflux and nothing special needs to be happening. You can see that after some time, it has changed colors and most of the piperine is dissolved. I seem to always be cursed with orange chemistry. After some time, you'll notice that everything dissolves and your solution is quite clear. You'll see after a while that it will actually start to precipitate something else out of solution. Let's look at the reaction of what's happening. The first thing that happens is the hydroxide anion acts as a nucleophile and attacks the carbonyl group. This is very unstable, and the carbonyl group will reform, making a double bond, and then the piperidine, which will eventually be formed, is kicked out. Since we have potassium hydroxide, this will stay as a carboxylate anion, and it'll make a potassium salt out of it, which is not soluble in the ethanol. Here, you can see that salt being precipitated out since it's not soluble anymore, and the solution got a lot more cloudy and opaque. That white ring that you see above the solution is the potassium piperinate. After we've refluxed for about 2 to 3 hours, you can see that there's a large amount of the potassium piperinate salt at the bottom. We're now going to distill to dryness, so we just have the salt and none of the ethanol, water, or piperidine. It's going to be very important to keep strong stirring, and it's also going to be important to slowly heat this up and to slowly distill it. If we decide to heat the mixture too fast, it is possible that we'll burn the product, and it's really not going to be so good. Even though I heated it slowly and at a low temperature, I still managed to burn part of my product. I would recommend to use a vacuum distillation, however regular distillation works as well. Bumping was also a huge problem for me, and the stirring didn't really help at all. Now when you distill over, you're going to get 3 different fractions. 78C is ethanol, 100C is water, and 106C is piperidine. I decided to discard this as I have no use for it, but you can turn it into piperidine HCl. As you can see, as it got closer to dryness, you can see those small burn marks in the center of the flask. Once everything was dry enough, I added 300 milliliters of water to the flask. The potassium piperinate is very soluble in water, and everything should dissolve into it. I also had to wash the sides of the flask because I tried to use the vacuum, but I guess my setup was not cool enough and kind of exploded. You will see copious amounts of vapors coming off. That is fine, just make sure you're in a well-ventilated area. We're now going to stir the solution until everything has dissolved and make sure that nothing is left undissolved. I was worried it wasn't going to dissolve since I burned it, however, it fully dissolved after some strong stirring and letting it stir for a while. You can see some of those big chunks at the bottom really get thrown around, and it really did take some time to dissolve all this. After I felt like everything had dissolved, I set it for a filtration just to make sure that any piperine that decided not to react or any other material that wasn't dissolved could get caught in the filter. Luckily, when I did the filtration, nothing was really left into the filter paper and I had a pretty much clear solution. The filtrate was put into a new Erlenmeyer flask and we're going to set up for the next step. The next step will be the addition of hydrochloric acid so we can turn this into piperinic acid. The procedure that I followed called for 36% hydrochloric acid, however I only had muriatic acid so I had to add a little bit more than what was normal. The procedure called for around 90 with 36% hydrochloric acid, so I got somewhere in between about 120 to 150 with the muriatic acid. Mine was definitely overkill, however I just decided to put that much in there. We just want to make sure that it's in acidic conditions. You can see upon addition that we have a lot of vapor and a beige precipitate that comes out. I decided to turn on stirring just so everything can get mixed around and so I didn't have to add any more acid just in case. The stir bar really didn't seem to be doing anything effective, so eventually I had to just pick it up with my hands and swirl it around. After finding an excuse to do Hamilton's flask swirl, everything turned into a homogeneous mixture. This was represented by the solution being very opaque and that beige color. I also checked the pH of the solution and it was very acidic. This means that we don't need to add any more acid and that we're at the perfect pH. As you can see, the solution is quite thick and quite opaque with that beige color. We're now going to do a very long filtration as this goop is very thick and it does take forever to filter. You're also going to want to use a very fine filter paper as you don't want any of it being lost. The filtrate should be a very clear solution with no signs of the piperinic acid being in there. What we're left with is this beige paste that kind of has a bubblegum smell to it. It was then put into the oven at about 100 to 120 degrees Celsius so it can fully dry. Here's what it looked like after drying for 12 hours, and they're very, very solid rocks. I ended up using a blender and I blended it down into a powder. Apparently I broke the laws of chemistry and got 145.6% yield. I do think this is not as dry as I thought it was, even though I put it in the oven for like 12 hours straight. For some reason, I didn't realize this till I was editing, and I guess I need to dry this powder out a little bit more. Alright, step 3, piperinic acid to piperonal. We're going to need 3 different solutions, solution A, B, and C, and they will all be used in the oxidation of piperinic acid. Solution A will have 3.7 grams of piperinic acid, 0.69 grams of sodium hydroxide, and 100 milliliters of water. We're now going to add the sodium hydroxide to the water. The reason for this is the piperinic acid is more soluble in basic conditions. Dissolving will take some time, and make sure that it's fully dissolved before you move on. I did try to get mine to fully dissolve, but there was a few granules left inside, but that wasn't that big of a deal. I did decide to add about 0.05 grams more of the sodium hydroxide, as I didn't think it would affect the reaction that much. I was just trying to get the rest of the piperinic acid to dissolve. Solution B will essentially be our oxidizer solution, and that's going to be 500 milliliters of water, 3.9 grams of potassium periiodate, 5.4 grams of potassium permanganate, and that's just about it. The potassium periiodate will be added first, and it's a really good idea that if you have any chunks, is to crush that up into a powder. It's not as soluble as you would think it would be, and it does take some time to really get it down into solution. Even then, I still had trouble dissolving all of it. The potassium permanganate was added, and you can see our solution turns into a very beautiful purple color. The potassium periiodate may not play a role in this, but ChemPlayer did say that it did help him get a better yield and a lot more purity. Solution C will essentially be the cock block of the oxidation, and we're hopefully going to stop it at the aldehyde stage rather than the carboxylic acid stage. This solution will be added to the mixture once we're done reacting. It's important that you have this pre-mixed rather than trying to mix it right before you have to add it in. Make sure both of these are dissolved before continuing on. It's important that all solutions are dissolved before continuing. We're now going to add some ice cubes to solution A to slow down the reaction as much as we can. We're trying to slow this down as much as we can, and adding a few ice cubes can help with this process. I added a total of 4 ice cubes, and that seemed to work for me. You're going to give solution B another stir right before you add this in. Try to add this as quickly as possible so you can get all solids in there if they're not already dissolved. You'll see the solution turn a brown color upon the addition of the oxidizers. You're going to let this reaction run for a maximum of 2 minutes. After the 2 minutes are up, you're going to add the quench solution and make sure that it's thoroughly stirred. Let this stir for a little bit, and then you're ready for the next step after this. Let's see how this happens. So the first part, the potassium permanganate, is going to make a diol with the alkene. This will then further react with either the potassium permanganate or the potassium periodate. This will then form the aldehyde, which is what we want for our reaction. This is also why we added the ice cubes and limit the reaction time, so we stop here instead of the carboxylic acid. The oxidative cleavage by potassium permanganate starts with the addition to the pi bond, forming a cyclic intermediate, which then eventually breaks down into an aldehyde or a ketone. We also limit the reaction again with the ice cubes in the 2 minutes, so we stop at this part and not fully go to the carboxylic acid. And that brown precipitate that you see is the manganese dioxide. Alright, back to the video. I also let the solution sit for a little bit just so you can see the precipitate that comes out. We don't care about this precipitate at all, and we're going to filter this entire solution. You're going to want to use a very fine filter paper again, just because you really don't want any of these particles and precipitates to go into your solution. You're then going to wash with 30 milliliters of water. I actually rinsed the reaction vessel with the water. You can also use a spatula to move things around, just to make sure that everything is filtered through with the washing of the water. Let me tell you right now, this is going to take forever. Though as you can see, the filtrate is very clear and it's a nice yellow solution. Even the liquid alone has a very nice aroma to it. We're then going to wash this with 2 30 milliliter portions of dichloromethane. This is actually our extraction solvent, and it also washes the precipitate just to make sure that we have all of the piperonal in solution. It's a good idea to move things around with your spatula just to make sure that you can get all the DCM across the precipitate. Also, to let you guys know, that brown precipitate is very annoying to clean out of your funnel. It is very sticky and it loves to just sit right on the sides of your funnel and not come off. As I let the DCM run through the precipitate, I set up for a separatory funnel on a ring stand. Piperonal is a lot more soluble in the DCM layer, and it should go to that. When I pour the filtrate into the funnel, you can see at the very end all of the DCM go to the bottom. Once everything is in, we're going to shake the funnel around and make sure that we coat everything with the DCM. This is to ensure that we get all of the piperonal into the DCM layer, and so we can separate it out. Once everything was shaken, I let it to settle for a little bit so both of the layers can separate. Once everything had separated, I got a fresh beaker and I separated the DCM layer into that. Naturally, I forgot that the stopcock was on and my flow was very slow. Once I took it off, everything flowed very nicely and I got my DCM layer. Even though the DCM smell took over, I could smell a very sweet, buttery aroma coming from it. The aqueous layer is extracted one more time with 15 milliliters of DCM. This is to make sure that we have all of our piperonal extracted from the aqueous layer. It's then put into our previous organic layer. Both extractions will be dried over a drying agent. For me, I decided to use 3A molecular sieves, as that was just what I had on hand. I put some molecular sieves into my solution, and I let it dry until everything was clear. Though a good idea would be 30 minutes to an hour, just to make sure that you have all the water out of it. You'll then filter the organic layer from the drying agent, and you'll put that into a new container. You'll then evaporate off your DCM layer, and your piperonal should be at the bottom. I decided to use a fan-assisted evaporation, but that ended up being a bad idea as it pulled a lot of moisture in from the air. I ended up having quite a bit of water into mine, and it really wasn't a good idea. Fortunately, piperonal is not really soluble in water, and I just filtered this out. And here's what it looked like after being filtered. I then let it dry in the open air, and this took some time since it was water evaporating off of it. In the end, I got about 0.14 grams, which is about 5.6%. This usually has a percent yield of around 20%, however, I really didn't get that high, and I'm trying to think exactly what I did wrong. If anyone has any advice or anything they want to share, please put it down in the comments as I read every single one of them. The heat from my hands was able to melt this, and that's pretty close to the literature melting point of piperonal. Now let's talk about the smell. The smell is one of the most beautiful things, and you're going to want to smell it all the time. It smells exactly like vanilla, butter, and maraschino cherries mixed together. I have been looking at different ways to make piperonal, and I saw one using potassium permanganate and THF, and I'm reading about the paper right now to see if I can actually do it. That method has reported around 80% yield, and I'm quite interested in doing it. Overall, all of these steps were really fun, and I had a good time doing the chemistry. Hopefully you guys enjoyed the video as well. Please subscribe as it really keeps me going, and I really love when all you guys do that. I just want to thank all of my Patreons. You guys help the channel so much and deserve appreciation. If you have any ideas of how I can be more appreciative towards you, please post it on the Patreon, and I'll try my best to do that. Other than that, the video is over. You can do whatever now and stop watching.